Okay, so for geometry, section 4.1, we're starting a new chapter. We're dealing a lot with angles and relationships triangles and relationships in those triangles. So first of all, we're going to review a few things um, and see what we know. So first of all, we can classify triangles. We can classify them by their angles. Okay, maybe I should underline that instead. Um, so much for my highlighter. I never like it when I use it. All right, so we can classify triangles by their angles. Okay, so they are acute triangles when they have 3 acute angles. They are a right angle when they have 1 right angle. But notice, okay, you need to know some terms if you didn't learn them in algebra. You need to know some terms. That from the right angle, there is a leg, 2 legs come out of the right angle. The side opposite of the right angle is called the hypotenuse. All right, and then we have an obtuse angle, okay, or an obtuse triangle where we have 1 obtuse angle. Remember, that's over 180 degrees. The other way we can classify triangles is we classify them by their side lengths. So a scalene triangle has no congruent sides, so there are no markings to make it scalene. An isosceles triangle has 2 congruent sides. The book says at least 2, which is interesting to me because it should only have 2. If it has 3, it's a different shape. But notice it has these markings, right, that these 2 sides are congruent. It also has some names to it that you need to know if you don't already know. Okay, so the 2 congruent sides are called legs, just like we had legs on a right triangle. The one side that's not congruent is called the base. It doesn't have to be on the bottom. It can be oriented any way. It's just the one side that is not congruent. Okay, and then from the base, we have a base angle on both sides. Okay, so these are base angles, and they're congruent. And then the angle across from the base, right? So the base is here. The angle across from that is called the vertex angle. It's the one angle that's different in an isosceles triangle. And the last way to classify a triangle by its sides is equilateral, when all 3 sides are congruent. Okay, so different ways to classify triangles. We're going to use both of them a lot. Okay, so then next, we can have an extra line or segment on a drawing. It's called an auxiliary line. Okay, so right here would be this dash line through here is an auxiliary line. So it's an extra line or segment. It is sometimes needed in a proof. But if we use it, it must be justified. We're not going to use them today and put them in, but it is justified by the protractor postulate, okay, which justifies the introduction of a line that forms an angle with a given measure. So there are going to be some other lines out there that are helpful, but we're not forming one today. Okay, so then let's get into some theorems. Again, we're going to use these things. I've said before, if the theorem has a special name, we're probably going to, you probably need to highlight it in your notes. Highlight it in that packet of postulates and theorems that you can use on your tests. Like those are the ones we're going to be using the most often, typically. All right, so the triangle angle sum theorem is the sum of the measures of the angles of any triangle is 180 degrees. You all tell me this all the time. Okay, so if I have this angle, and this is A, B, and C, all this is saying is that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. That's all that theorem is saying, but we're going to use it a lot. Okay, some corollaries that we have. The acute angles of a right triangle are complementary. What does complementary mean? Hopefully you said, hey, 90 degrees. You might want to write that in there. Okay, so if we think about that, it says the acute angles of a right triangle. So if I have a right triangle, okay, and this angle is right, well, this angle and this angle have to add to equal 90 degrees. Sorry, my degree sign got a little big there. So we have to add those two angles to equal 90 degrees. Well, that makes sense because we know the whole triangle is 180. And so if we have a right triangle, the right angle is 90. The other two have to be 90 as well. Okay, that's a corollary, but you know that the acute angles have to equal 90. The other corollary that you can do or use is each angle in an equal angular triangle. So equal means equal, angular means angles. So each angle in an equal angular triangle, so a triangle with equal angles, has a measure of 60 degrees. Again, you have a triangle. All three angles are equal, so that means you're taking 180, dividing it by 3, and you're getting 60 degrees. Like, okay, I get this. Duh, maybe is what you're thinking. I don't know. But those are helpful corollaries. All right, this other one, it's a really fancy name here we've got. It's a AA to an AAA, or AA to AAA theorem. What that says is if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. All right, so if you have this triangle, or these two triangles, okay, and you know these two are right, so they both have to be 90 degrees. These two are marked congruent, okay, so you have two angles that are congruent. Then you know that this third angle has to also be congruent. So you know that all three angles, A stands for angles, are congruent. Okay, so both of those theorems we're going to use today in class, and we're going to use in your homework. Okay, so if you know two angles are congruent in a triangle, then you know the third one is congruent. Okay, let's go to the back. Example 1. Okay, so I've got the work here for you because I want to focus on finding the relationship. It says find the measure of each numbered angle. Okay, great. But how do I do that? So if I look at this, I have a small triangle right here. Okay, and I know, right? I know that the sum of all the angles in a triangle has to be 180 degrees. So I have written this equation. The measure of angle 1 plus 36 plus 60 equals 180. I know that has to be true. But only one angle is unknown. And I can solve. If I have one unknown or one variable, I can solve it. That's important. So then I solve this. 36 plus 60 is 96. I subtract 96. The measure of angle 1 is 84 because the sum of the angles in a triangle equals 180 degrees. So I could solve for that angle 1. I got it. I'm good. Now that I know that angle 1 is 84 degrees, okay, I can write that in there. How do I find the other angles? And there's a lot of ways you can look at this, okay? I immediately went to like, hey, I like straight lines, okay? This is a straight line. So this angle 1 and angle 2, they're a linear pair, right? They're side by side. They make up a line. So I know linear pairs or linear pair angles equal 180 degrees because it's a straight line. So I set up this equation. A measure of angle 1 plus the measure of angle 2 has to equal 180, okay, because they're a linear pair. So 84 plus the measure of angle 2 is 180. I subtract 84, get the measure of 82, or angle 2 is 96 degrees. Awesome, I'm making some fantastic progress here because now, let me erase that line. Okay, now I've got 2 angles found and I only have one more angle to go, angle 3, which magically is a part of a lot of different triangles. So I can look at the little triangle and say, hey, 96 plus 45 plus the measure of angle 3 has to equal 180. Or I can look at it as a big angle. Okay, that takes a little bit longer because these two would combine together to be one angle. So I could say, well, 36 plus 60 plus 45 plus the measure of angle 3 equals 180. So I can solve either one of those. Okay, I chose the measure of angle 2, the measure of angle 3, and 45. So I chose the small triangle, but I want you to see like there's all kinds of relationships. Again, it's like a treasure map. You can solve it lots of different ways. Okay, so I chose this one, the 96 plus 45 plus the measure of angle 3, and I found out that the measure of angle 3 is 39 degrees. But again, looking at the relationships, are they linear pairs? Are they all the angles of a triangle? Are they vertical angles? Or if we're looking at parallel lines, which we're kind of out of that section right now, but if we're looking at parallel lines, are they alternate interior, alternate exterior, corresponding, consecutive interior? All of those things, all of that vocabulary keeps building and we're going to keep using. Okay, so switching gears a little bit, learning some, getting some new, more vocabulary in there. We've got an exterior angle of a triangle forms a linear pair with one of the angles in the triangle. So this is, angle 2 is our exterior angle right here. That's the exterior angle. It's outside of the triangle. But what it's saying is that linear, or the this exterior angle forms a linear pair with the angle it's beside. So angle 1 plus angle 2 equals 180. And it should say the measure of, but we're going to write it in some shorthand. So it makes a linear pair. They have to equal 180. That's going to be helpful. Now, we also have remote interior angles. Okay, so these are in relationship to our exterior angle. So the remote interior angles of an exterior angle are the 2 angles of the triangle that are not touching the exterior angle. Okay, so angle 1 touches angle 2. That's not remote. Angle 4 doesn't touch, and angle 5 doesn't touch. So 4 and 5 are called the remote interior angles. Now we have this really awesome theorem, the exterior angle theorem. Okay, it's going to relate to these things. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of its 2 remote interior angles. Say what? In this case, that's saying the measure of angle 2 is equal to the measure of angle 4 plus the measure of angle 5. Okay, because the triangle, all the angles, all 3 angles in a triangle equal 180 degrees. And the sum of these 2 angles equals 180 degrees. So the only thing, it's like using that transitive property that we can kind of think about this. But that's what it's saying, is this exterior angle is equal to the sum of the 2 remote interior angles. And that's going to be necessary and helpful in example 2. All right, so unfortunately I do have to erase my stuff here so I can move on down. Maybe we can get started. I'll leave it. We can get started. on it. So example 2 says find the value of x and the measures of angle W. So angle W is here, and angle XYZ. So angle XYZ. Okay, so again, I said we're going to use this exterior angle theorem right here. So if we do that, okay, where is our exterior angle here? Awesome, it's this one. It's the XYZ. This is our exterior angle. Okay, so we know the exterior angle is equal to the sum of the remote interior angles. Well, what are the remote interior angles? Good, 64. So remote interior angle is 64, and this 5x plus 3. So that's where this equation came from. 13x minus 5 equals the quantity 5x plus 3 plus 64. Okay, so these are the remote interior angles that equal the exterior angle. And then we solve. Okay, so we subtract 5x, we add 5 to both sides, okay, and we get that x equals 9. Once again, like this is the algebra behind it. I believe that you can do the algebra. So I'm giving it to you so we can talk about the relationship more, and then you can get to practicing more in class, hopefully. All right, so then we have to solve for our angles. So you plug the 5 in for x, and you solve, and you get 48 degrees is the measure of angle W, and you plug 9 in for x on the other one here, and you get 112 degrees is the measure of angle XYZ. So that exterior angle. Okay, so hopefully talking about the relationships more is going to help us see them and be able to point them out and recognize them yourself when you're like working on it in class or at home, or to talk about it. So homework is 1 through 15 odd, 21 to 31 odd, 37 and 39, and scratch the others. We've got plenty there to do. So good luck, and I'll see you.